Hello everyone, welcome back to my channel. I've come up with another video and let's see what it is about. So in this video, we'll be learning about stationary distribution of regular Markov chain. First, let's see what is regular Markov chain. A stochastic matrix is said to be a regular stochastic matrix if all the entries, which is p to the power n, are positive. And let's see an example for this regular stochastic matrix. We have a weather model here and it represents three different weather conditions: sunny, cloudy, and rainy. And here is the transition probability between these three states. So here, as you can see this matrix, the first one, 0.7. If we consider the first element, it shows like on a sunny day, what is the probability of the next day being sunny, of the next day being cloudy, and the next day being rainy? That is what the first row represents. So that is 70% of the next day being sunny, 20% of the next day being cloudy, and 10% of the next day being rainy. When you come to the second row, 0.4, 0.4, 0.2, it represents that the present day is cloudy and the percentage or the probability of the next day being sunny, cloudy, and rainy. That is 40% sunny, 40% cloudy, 20% rainy. And same in the next row, 0.3, 0.3, 0.4, it represents the present day as rainy and the probability of the next day being sunny, which is 30%, or the next day being cloudy, which is 30%, or the next day being rainy, which is 40%. This is an example of regular Markov chain. So let us see what is stationary distribution of regular Markov chain. The stationary distribution of regular Markov chain is a probability distribution that remains unchanged over time as the chain transition between states. So let's see an example to understand more. We had taken the weather model previously for regular Markov chain. Let's take the same example here. This is the same model, weather model, which we have taken. And if we have to find the stationary distribution, phi is equals to x, y, z, such that pi p is equals to pi. Pi is just a variable here, which we represent the stationary distribution. And we have already given here that it is x, y, z here. Let's see an example for this regular Markov chain. Oh yeah, this is the form pi p is equals to pi. If we solve this representation given here, pi p is equals to pi, we get three equations, as you can see here. Normal matrix multiplication, if we do that, we get these three equations present here. And if we solve these three equations, we'll get values for x, y, and z, the variables. And after solving those three equations, we have got x is equals to 5 by 11, y is equals to 4 by 11, and z is equals to 2 by 11. And therefore, the stationary distribution, as we have represented here before, y is equals to x, y, z. Here, after solving, it's 5 by 11, 4 by 11, and 2 by 11. We just substitute the values of x, y, and z. Let's solve a few problems on them to understand more better. Problem 1. The first problem, consider a regular Markov chain with the following transition probability matrix. Here is the matrix 0.4, 0.6, 0.2, 0.8. Now determine the stationary distribution of this Markov chain. So the solution is, we have known the conditions like the stationary distribution pi, it should satisfy pi p is equals to pi. And since this is a 2 into 2 matrix, the pi will be equals to x, y. And here the equation pi p is equals to pi can be written as xy into the matrix P is equals to xy. And we solve, after solving that matrix multiplication, we get these two equations. And after solving these two equations, we'll get the values for x and y as 2 by 3 and 1 by 3. So therefore, the stationary distribution is 2 by 3, 1 by 3. Let's go on to the next problem. This is a similar one, but it is a 3 into 3 matrix. Consider a regular Markov chain with the following transition probability matrix and determine the stationary distribution of this Markov chain. And since in the previous problem, it was 2 into 2 matrix, we had taken pi is equals to x comma y. Here it is a 3 into 3 matrix. So the unknown variables, it will be 3, pi is equals to x comma y comma z. And pi p is equals to pi can be written in this form. Pi into the p matrix is equals to x comma y comma z. And if we solve the matrix multiplication, we get these three equations. And if we solve those three equations, we'll get x is equals to 5 by 8, y is equals to 3 by 8, and z is equals to 0. Therefore, the stationary distribution of that particular Markov chain is 5 by 3, 3 by 8, 0. That's all for today's video. Thank you, everyone. See you again in the next video. Bye-bye.